the recording is taking, we started officially now the lecture, guys. So welcome to this online lecture. And I'm happy to see you safe and well. Okay. I will delete this from the recording. I'm lagging myself. I don't know what I want to talk about. So today we have a new chapter, chapter 11. And when we open, I was talking about the recording, guys. Yes. The recording took yesterday around 1 hour and a half to be available to me to post it, not for your class, for another class. So if I am late on posting the recording, it's not because I am late, because they are late to send me the recording processed. This is an issue. And this is the chapter. And one thing also I used to do, guys, and it was giving me a problem whether I use the whiteboard of Zoom like Levon said, or whether I use the online whiteboard, or whether this and that. And finally, I remembered that, look at this. I can do annotate on the page itself. I forgot about that. Now I remember, it makes my life much easier. So I can write now on the page that I am in. So if I take out this, I'll stop this for the time being. And if I do a slideshow to take the one to the left and from beginning, and this is a much better page. Now, if I go to annotate, it will give me more space to annotate. You see? Now, this color I don't like, masalan. Let me choose something that is dark, like this red. And I think I can also increase the anything. I can delete everything from here. So clear all and we are set, Yesterday it gave me lots of problems with the Asil talking about the commercial and something like this. Anyways, today's lecture is about instruction sets, but before we start, let me finalize what we were talking about last time, and I said I will elaborate on it today. So if I have this number, let's take a number with 4 digits only, 4 bits only, guys. This number, and we want to know, this is assumingly 2's complement represented with a negative number to the left. So we have talked about this a lot, but I wanted to know this exactly, how do I calculate it myself? And there were 3 types, 1's complement and magnitude, 5 magnitude or something. So the one that I use, and I did it at the beginning, but anyways, now let's not talk about what happened. Well, how do we go about this? We take the number of digits without taking the last one. This is a signed number, guys. Remember, this is a signed number. So the last bit to the left is 1 or 0, and they are not counted in what I'm doing. So what's the largest number that can be represented here, guys? The largest number that can be represented here, 101, 2 to the power 3 is 8, right? So the largest number is minus 8. Minus 8. Plus. All the ones you take into consideration. So this is 1, as we say, 2 to the power. This is 1 in binary. This is 2 in binary. And this is 4 in binary, right? This is 5 in binary. So 5 and 1 is 6 plus 6, and this is equal to minus 2. This is equal to minus 2 in the signed numbers in 2's complement. Minus 2. Here it is. This is how we calculate. First of all, 2 to the power 3 at dash. 2 to the power 3 because you don't take the last digit to the left. 2 to the power 3 is 8. Assumingly this is minus 8. And then you add to it whatever the ones represent, and this will give you the answer. Okay, if we take one with the larger number, but with a few ones, guys. So let's take 8 bits. 1 0 0 0 1 0 0 1. According to this, can anyone please calculate and give me what's this number is? Please do the calculation as if we are in person in class and give me the answer, and then we will do it together. Give me the answer, please. According to this, I just mentioned what's the procedure for that. Give me an answer. This will sound bad on the recording. You might think that the recording is off, but I have to see that at least 1 or 2 students got that, and they give me the result. It will not take long. You just need a paper and a pen and tell me. Mark, raise hand. تفضل Mark.
minus 247.
Minus 247. Let's see this, if everybody will work with that. Minus 247. Anybody else, guys? Okay. The procedure goes like this. This is 8 bits, so they are 7 bits to take into consideration. 2 to power 7 is a dash. Last time I said 126, 127, and I was going crazy last time. 2 to power 7 is a dash, Mark. 128. Correct me if I'm wrong, please, guys. And this is the minus. And plus. What do we add to it? We add to it 1 here. And this is what? 2. This is 4. And this is 8, right? So plus 9. Plus 9. And minus 128 plus 9. This is 119. Minus 119. Minus 119. If I didn't, 980 مظبوط. Okay, let's check if I'm right or Mark is right. I'm not claiming that I'm right. Let me see the result. Where is the? Oh, wait a minute. I need to go. How do I minimize? Like, I always put myself in problem, guys. ليه؟ لأنه I put this in larger mode. Now I need. Let me see here. But how do I make it less? I want to see what's on the back. It's not allow me. Control what, guys? Do you know?
Press escape.
Alt tab
Alt tab.
to switch the tabs.
Alt tab. I want to go down. I want to minimize the screen. I don't want to show it on my whole screen. This one, it's taking on my whole screen. I don't see the tabs and I don't see anything.
Press exit.
Exit?
Not exit, escape.
Escape. Escape. Thank you.
Yeah.
Thank you. Yes, yes, it is. So what I was trying to go is go to Moodle. Moodle always help us, Michelle, with the new window, and just give him the number. What is شو هلا 10001001 مظبوط. Did I write it right? 10001001
Yes, it's correct.
شو عطى الجواب؟ ايه
لا، عم
correct.
بحكي عن
Okay, given in 2's complement what is 1 in decimal given, I don't know if I don't know, we will see, minus 119. Okay, so this is the answer, and I don't know if Mark took the 2 to the power 8, 256 instead of 2 to the power. I don't want this. I don't want to crowd myself with the different screens. Maybe he took 256. It will give 247, 250. Yes. So Mark and everybody, when I started here with 4 bits, I said you take the 3 bits. You don't consider this because it's signed number. And if you remember also in Java 1, I might have talked about it, that when you declare an integer in Java, it will reserve like 16 bits for it or 32 bits for it. So integer, it will reserve 32 bits. So it goes to 4 billion. While when you say signed integer, it will drop one digit to the left, and it will be then 2 to the power 31, and it will be 2 billion rather than 4 billion. And I'm telling you, this teaching I don't like because I can't see your faces. Looking at your faces, I would tell whether you are catching what I'm saying or not, but I have to go with that. No, yes, you are catching what I'm saying. طيب, what now do I want to do? Go back to this because now we can know how, I know at least how to escape, and it will give me that. And then we go back to the annotate, we declare clear the screen so we can go with our life with this chapter. Clear all drawings, and now we go there. طيب هلا okay, slide show. Wait a minute, I have to stop this لأنه I need to stop this so I can go and خلاص, keep moving between things, guys. Slideshow from beginning. So this will give the whole, yeah, now the annotate back, I'm going back and forth. Can I move down now? When I annotate, I cannot. So let me close the annotate and use it when needed. Okay, now we start the session after maybe 10 minutes of this and that. We talked about instruction set, guys, as functions and characteristics. And we said, this is a recap of what we did last time. And we said that we categorize them into transfer commands, input-output commands, storage command like load and movement, often called for storage and store and load. And what else we talked about them? We needed those shift, all kind of shift statements, shift left, shift right, arithmetic shift left, arithmetic shift right. I posted a document where it shows you exactly how this and that is done. So I can ask you about in the exam, why don't you arithmetic shift this number 2 times? And then you have to give me the answer. You should be able to do this. The recording is with you. So now we continue with this. Here. Addressing modes. Let me introduce the topic. Annotate. We said that we have a memory like this. From 0 to 16 gigabyte minus 1 to 16 giga. Why don't we say 16 gigabyte, guys? Because we don't know how many bytes there are in the same address. So if the chip is 16-bit chip, then this is 16 giga 2-byte address. So we say 16 giga addresses, مثل بالفون نيومان. We said 1000 addresses, and each address has 40 bits. So we say 16 giga. If we say 16 gigabyte, assuming that it is byte addressable, then it is 16 gigabyte. Yes, it means the same thing. طيب. If I'm building an instruction set, guys, and you know, building an instruction set goes with opcode first, and then operand, and address. Then send me address, بدل operand. I can have more than one here. It doesn't matter. The question is, how many bits you will, or you need, or you want to allocate to the address, guys? This is very important. How many bits you want to allocate to this address? Okay. If you want to say, for example, load, which this is an operand, this is an opcode, عفوا. Okay. Suppose I want to get to the end of this RAM. How many bits I need? 2 to the power what? Give me 16 giga. Giga is 30, with 16 is 4, so 34. So I need 34 bits for this. 34, the number is not 24, huh? There is 44. Yani memory of 2 to the power 34. Okay. What if my whole instruction is 32-bit? It will not work. صح ولا لا? If the whole instruction is 32-bit, How can I allocate one address to be 34? I cannot. Does it mean that if I have a computer of 32-bit computer or 32-bit word computer, I cannot have a 16 gigabyte RAM? This is not true. So how do they do this? I hope you understand the problem. Now the solution. I repeat, 32-bit instruction set. It has an opcode and the address and something else here, constant or something. We will talk about it. This was not in von Neumann, guys. Assume that it's like this, guys. Add M of the largest address in the memory. 216. Oh, too much. Comma 5. What does that mean, guys? Add 5 to this memory address and store it back. Okay, suppose this is the instruction. We are talking now, we are interested in one thing only. If this address is very, very large, how can everything then fits in 32-bit? It cannot. Then this alone needs 34 bits alone. So this will not work. It's not a computer. It's not a good design. It's not a working design. Not even working. Mish good or bad. Okay. So what they say is the following. What is the maximum size you want the address to go into this RAM? The RAM is 16 giga still. And then they say we will allow it to go to 16-bit only. 16-bit only. This, I will not give it 32-bit. I will give it 16-bit. Okay. How far I can go with 16-bit, guys? How far into the 16 giga? Like طلعوا 256. Let's say this is not 16-bit. Let's say this is what? 8 bits بس. هلا I tell you the difference. ما بدي 606. Suppose it's 8 bits. 8 bits يعني 1 2 3 4 5 6 7 8. How many addresses I can go far with these two 8 bits? 2 to the power 8 يعني maximum قديش؟ 256 addresses. 2 to the power 8 is 256. Yes. So from 0 to 255 bus. 250. Wow, this is very small memory. Very, very, very small memory. From there, now if it's 16-bit بتصير أكتر, guys. If it's مثلا you give it more, it will be more. Anyways, let's stick to what we have. 255 bus. How do I get to the rest of the memory then? Okay. In this case, the only solution to that, guys, is that the width of your word is more. يعني مش 1 byte, يعني 16 giga, 32 bit each. Here. So this is where your instruction can go. This is where your data can go. This is like von Neumann, guys. Data or addresses, right? So what do you write here? You write add this address, then all 112. Add memory of 112. This can be represented in 8 bits, مش هيك? 8 bits. Yes. Well. So it will jump to this memory location اللي هو at 12. And what will it see, guys? It will see an address. This will be an address now. It will not be the data needed. It will be an address that will take me all the way up to 2 to the power 32 bits. 2 bits. 2 to the power 32 bits, guys, can lead me maximum to 4 gigabyte RAM. So this can never be 16 giga in this computer, guys. 64 bit بصير غير يعني القصة. But for this one, the maximum I can reach is 2 to the power 32. يعني this RAM can be 4 giga max. 4 giga. 4 giga addresses. I cannot get to them directly from the address specified in the instruction yet. If we know, or if we can find a way to say to the CPU that this address, this address is actually not the address of the data that I'm using. Instead, it's the address in the RAM, where that is an address that will lead me to the last address in the RAM. Oh my God. Oh my God. Oh my God. Look, I'm going to write something in Notepad, and maybe, hopefully, inshallah, I will explain better. Now, look, I'm doing escape and it's not going down. You told me last time to do it. Yeah, now it did it. Yes, okay. So now this is escape. But I minimize now. Okay. Now I want to start a notepad session. Notepad session. Where is the notepad? Okay, let me create a new file. When a new file? New file. I should take the annotate out لأنهم حطت لي على الشاشة clear screen. And what did I say? New presentation. What is this?
كبست على
Close it.
البرزنتيشن
Yes,
دكتور علي.
yes.
عملنا مينيمايز إذا بدك ما تسكرها.
هيدي شو هي؟ شو هي هاي؟ The chapter. This is the chapter. What is this? Wait a minute. Oh no. Okay. But I don't want this one. So this one, file, new show, new tab. I want a new file. Okay, new tab. Okay, whatever. Look, guys, I'm gonna write a program here. English-like program. Load I. This is the new command. It was not Van Neumann, guys, but it is in contemporary computers. I didn't even start the chapter, imagine. Load I, memory of 5, add memory of 15, 16, 15, whatever. حتى ما يكونوا 5 و5, 17. Store indirect in memory of I wrote already memory of 29. Yalla. 29 will be away, but let me now I know what I'm doing. Let me know. This is 6 best. Yeah, but I can do that, guys, and what? I can do this and then I leave spaces there. Let me see this if it works. طول بالك. Now what do I need? I need the data, مش هيك? So in 5 I'm gonna write 2000 يلا 200,000 خلينا على الخفيف guys. خلينا على الخفيف 2001 هيك خلينا على الخفيف. And then in in what? In okay, go back. This means continue with the RAM. And in 17, what do I have, guys? Suppose I have -3. Yalla. And in memory. And then what? 6. Wait a minute. Okay, wait a minute. In 6, مش هي 6? Yes. In 6, I will put, for example, 1,520. Okay. Let's run this program, guys, together. This is using indirect mode. Load I. I have to continue with the data. 2001 لا خليني بدي احط اللي قبل مين 1520. And then نقطة, and then what? 2000 0 1 and continue with the RAM. Okay, this is how my RAM will look like. Let me tell you here, guys. Can I annotate? Yes, I can annotate, I think. Let me see, but then I will not be able to write. خليني not be able to write. Okay, guys. This is my instruction set. It is simple. This is for opcode. This is for address, and this is for constant. فازن. This is the opcode. I'm designing an instruction set, guys. This is an address. And this is a constant here. It can go, okay. No one can tell me that I cannot design an instruction set like this. Let's see if this go well with this, guys. With a constant. Okay, I'm not using the constant. I can put here comma 0, comma 0. You know what? Let me take this out كمان. هيدي ما بدي إياها. Okay, this is my instruction set, guys. This is my instruction set. Only opcode and address. And it's 16-bit only. 16-bit. Many bits, 16-bit, 16-bit. 16-bit. Let me see if it will work now with 16-bit. 16-bit. So قد ايه بدي اخلي لهيدا الاد لحتى يقدر يوصل لل 2101 2 to power قديش بيعطي 2101 جايز 2000 يعني بدي 10 اتليست يعني بدي 2K بدي اوكي بدي اوكي so this is 14 bits 14 bit for the address no I don't want that okay I want 10 bits for address, 10 bits for the address. Okay, 10 bit for address, 10 bit for address. And I want 5 bits for opcode, 6 bit for opcode, 6 bit. طيب. خلاص, I finished designing my instruction set. And look, it's all in all 16 bits. So my RAM is 16 bit. And my RAM is 16 bit, remember. And I write instructions or I write data. So this is my program, guys. I copy paste this here and now I'm gonna run my program. Load I. Now we are introducing indirect memory addressing. It means that the CPU will go to M of 5. Can I represent 5 in 10 bits? Of course, and 10 bit can take me to 1024, right? The largest number I can go through in here, the largest number I can type here is 1024. So 5 is legitimate. So this is legitimate command. With 17 is legitimate command, and 6 is legitimate command. لأنه هيون الأدرس is less than 1024 that the 10 bits can represent. Now it says go to location 5. So it came to location 5. And because it's indirect addressing, it will take this address now and move further in the RAM up to 4K. Or 2K is enough. 2K, yes, 2K is enough. 2K is enough. So my RAM, guys, runs from 0 to 2K addresses. 2K addresses. Each address is 16-bit. And this is the end of the story. Now, when I go to 2010, what do I find? Sorry, when I go to 5, what do I find? 2101. So it will go now down to 2101. Did I put any number there? Here. I should put a number here. Suppose here I have 13. This is the data. Now, this is what will be stored in AC, guys. At the end of execution of this instruction, guys, I will have 13 in. This summarizes, maybe I took 20 minutes, 18 minutes now. We are into more, half an hour. But maybe okay, about timing. Do you understand? Look, I want each one of you, please, to chat with me and tell me something. Wait a minute. Where is this? Let me go back to this and let me open the chat. Where is the chat? Let me stop this and let me open the chat. Yalla, please. I want you to tell me one by one that you understand. You just say on the chat. You say, yes, I get it. I will get it better. I understand the idea, but I will get it better in the recording. Talk to me. مش هتضلني اقعد احكي لحالي انا. Okay, Maya say, okay, yalla, please guys, live on. Yes, 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 Agop. Mark, yes, thank you, Ahmed, yes, yes. Just help me to keep going. Thank you, thank you, thank you, guys. It helps me to keep going. طيب. If I go back to the notepad and continue, did I close it? No, I didn't close it. So if I minimize this back, minimize it, and go, let me see if the notepad is at the back. Yes, it is at the back. And here, if I continue with the example, guys, then M of 5, لأنه indirect, it will go to the 5, it will see an address in the RAM, يعني هون, it will go to 1000, it will load this. If we continue, add the M17. Now, M17 here, guys, it's direct memory. So it goes to the 17 and finds the number. It doesn't find an address. I didn't say add indirect. So مش لأنه I have indirect, always indirect. So I have direct mode and indirect mode. So this is the direct mode. It will go to the 17 and pick the number. And when we say add this, it will add to the AC. مش هيك شو بصير ال AC? AC will become a 10. I'm trying to annotate. And this will be 13 minus 3, لأنه I'm adding, that's 10. Now what? Store I in M of 6. It will go to 6. It will see 1520. It will go to 1520 and stores here شو? مش minus 10, 10. Repeat this recording 100 times until you understand what I was talking about. لأنه the whole chapter is about this, guys. I forgot to take the drawings out. And now I go back to the chapter. Command stop annotating and go back to the chapter. Computer, no, to this. And now I continue. These, I was talking about this, guys, a minute ago. Indirect. I finished this one with a very big example. Now we're going to go through these, not taking the same time, but from understanding this indirect, you should understand the rest. So here we go now. We have immediate, we have direct, we have register indirect, displacement, and stack. All these are different addressing modes. Let's go through them. Immediate addressing. So now I can annotate, I think. Immediate addressing at 5, guys. Suppose I have in AC, I have 13. When I say add 5, what will happen to the AC, guys? What will happen? Mark? Anybody come in? What will happen to the AC according to this mode? Immediate addressing. Address field. 5 is the operand. ما في قدامها memory of 5. There is no memory of 5. So this is the constant that I was trying to introduce a minute ago. This is a constant, guys. So it will take the 5 and add it in AC, and this becomes an 18. Okay? So we have seen so far, مثلا, add indirect, where it goes to blah, 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 and get, and we have add immediate, which will pick up the constant itself and do whatever you want to do with it with the AC. This is easy. And the characteristic of this is good. I call it a constant, guys. Yani add memory of 5 comma constant. We have something like this, guys. A minute ago, I drew it. So you can have add. It's going to show in a minute why I'm doing it now. خلاص. It's going to show in a minute, guys. It's going to show in a minute. So stop this and go down. It is fast. What do we mean by limited range, guys? Why do we mean by limited range here for the field that we are using? it means if I'm separating this, remember we are always bound to number of bits here. لو عندي infinite number of bits كل شيء بسويه 100 يا أخي. بس we are limited to number of bits, so we have to divide them among things, among operands and opcodes. So he's saying that if you leave this مثلا with مثل ما قلنا a minute ago 10 bit, and then maybe you leave this with 4 bits and this with 2 bits, what does that mean for 16-bit computers, guys? I have 4 instructions only. These are bits, huh? These numbers. For 16-bit computer, guys, if I do this instruction set, what does that mean? This operand can be only 4 instructions. حتى von Neumann can 21. Anyways, it could be a special device, guys, مثل washing machine or I don't know, any machine. This can work on that. لأنه عنده بس stop, start, rewind, forward, and stop. These are 4 commands, so this can work, but it doesn't work on computers. Anyways, 10 bits for the memory address and 4 bits for the constant. So the largest number here that I can represent is 2 to the power 4 اللي هو بيطلع 16. So the number that I can write here is bound to the number of bits that are allowed in the instruction set. Hope you understand that. Yeah, annotate, move to the second one. Immediate addressing mode. Let me scratch these. كمان هيدي ما عجبتني كتير, going back and forth all the time. Clear all drawings, okay. Let me see what are options. بلكي clear automatic, clear my drawings, clear view drawings. ما بعرف لا. Okay. شو عم نعمل هلا هون؟ Immediate addressing mode, guys. Well, what is this? How does it work? Before I annotate, let's go with the here. We finish with so this is the direct. Add A. So what's A now? A is an address field. Like in the minute ago, the notepad, did I delete the notepad? لا هي. In here, guys, this is the direct. What does that mean? Go to memory, without this I, huh? Hey, this is direct. هيدي 100% direct. ليه؟ لأنه ما في add indirect. Add this memory location اللي هو 17, so you go directly to 17 and use it. This is called direct addressing, guys. Direct addressing. Add contents of cell A to accumulator. Cell A in the memory, huh? When we say cell A, يعني memory. لو this is constant, كان al constant مثل immediate a minute ago. Look in memory at address A and do it. He's saying. Single memory reference, we go one time to the memory and we get the number from memory of 5, like in the, or memory of what? Memory of 17, you go one to the memory and then into the CPU and you add to the AC. No additional calculation to work effective address. Effective address, guys, starts from where? Starts from indirect and on. لأنه هلا بعده الeffective address هو the address given by the user. Limited address space. مثل الرينج, guys. هلا whatever I mentioned concerning the limited address, the limited range, يعني كانوا 4 bits. The address space within the instruction set is limited. In the previous annotation that I was making on 2, 10, and 4, for this one, guys, it's 10 bits. لأنه memory address in the instruction that I said it was 16-bit and 2, 10, and 4, it means that 10 bits are the maximum address I can reach, and this is what we mean by limited address space. Okay, come in. This is supposed to be easy. Now we go to the one that, and here it is. So this is load M of 17. We go to the 17, we get it to the CPU, and we add. Here, indirect addressing. This is what I was talking about for 15 or 20 minutes. لأنه this is where actually all starts. لأنه the other ones we already know. يعني حتى فان نيومان كان يوز دايركت ميموري ادرس يعني، بس فان نيومان كان عنده كونستانت شيء؟ لا ما كان، بس 1 ادرس واللي هو اوب كود اند ادرس، بس ما كان في عنده 2 ادرسيز تو اد ا كونستانت اور something. So I've been talking about this all the time. So guys, what does that mean? Let's look into here and look. خلينا نشوف الصورة إذا في صورة, and here it is. In our, if we put both on my screen, guys, and look here. Load M of 5, this is 5, مظبوط? It went to the 5 here, and look at the pointer. This pointer يعني هو هذا 2001, 2101. It's take me all the way to the actual operand. So this is address to operand. As I said, I talked about it a lot, so I'm not going to talk about it anymore. And I go back and see the characteristics of it. Multiple memory accesses to find the operand. Multiple. ليه؟ لأنه أول مرة بتروح بتلاقي address, وبترجع بتروح بتلاقي الأوبرند. So multiple. Why is not saying twice, guys? Why is not saying twice? مين ملاحظ شيء بسكرين عم بيقول لك إنه it's multiple. It's not only 2 memory accesses. This may be nested. Maybe nested. What does that mean, guys? You go to the first address from the instruction to the address in memory. Address in memory will take you to another address in memory, and the address of memory will take you to another address of memory, and they are nested. Look here. Kill parentheses معناته this is the first one, this is M of A. M of A go to another M of A, and then M of A go to M of A. طبعا it becomes slower. What helps this, guys? What helps this to be effective? RISC or CISC? Which is more effective, guys, for these issues? RISC computer or CISC computers, according to what I was talking about last time? Hagop, are you there still with me? Which is better? RISC computer or CISC computer for these? Levon, أسيل, مين بده؟ محي الدين. Okay, I tell you, you don't want to say anything. RISC is better because, guys, we said we don't have something like this in RISC. In RISC, you go with one load into the memory, get the number, and store it in one of the 32 registers that are available in the process. And most likely, if you want to reference this address again, you don't go again 3-4 times into the RAM to get the number, because the number is already stored in the registers. Okay, having said that, now we continue. So we know the indirect and here. Register addressing. Now this is important, come in. This is the first time I'm going to introduce you guys registers in my instruction set. Von Neumann did not have that. Bella, Von Neumann uses MQ. Yeah. MQ was a register. Yes. So we have the opcode. We have here address. Address يعني operand, مش هيك? This is address. This is not an address. This is a register. And this is the register number, guys. Register number. And this is constant. Oh my God. What kind of instruction is this? We don't usually see them together, guys. We don't see them together like this. But I'm just giving you an example of what can an instruction set look like. An operand is working on an address. It could be indirect كمان, huh? This is the ultimate of everything that can happen on a computer, guys. And then in this specific, مش كلهم بيكونوا بيستعملوا نفس الشكل, guys, huh? Suppose this is a subtract instruction or jump instruction or whatever. I don't know what. So you get the number in this address. You get the number in this register. You get the constant You add them all together and store them in AC. شو رأيك بهالinstruction? It is possible. I didn't see it in any other computer, guys. But this is the ultimate that can go in there. Well, no, كمان في يكون عندي 2 addresses, 2 registers and a constant. But we said before, don't build an instruction set with too many parameters in it. يعني operand 1, operand 2, operand. This is 3 operands, you see? One is memory address, one is register number, and this is constant. Let's take a simpler example like in here, guys, and let's use this suppose add. You know what? Let me do it here. Wait a minute. When Anna. On. Yeah. So I can write here. Yes. Okay. Before I store this, guys, I say load register 1, 25. And sure. Wait a minute. Wait a minute. Wait a minute. I cannot do this. No, I have to. Okay, I have to store this. Okay. Load R1, 25. Then add. Oh, wait a minute. Load. Load immediate M of 6. معلش كتبتها مع يلا بظبطها. load immediate M of 6. بعدين add register 1. Okay. I think this program will do it. We know what we were doing before, so I'm not going to go over this again. So far, what did I have in AC, guys? In AC, what did I have so far? AC is equal to شو قلنا? Load immediate M5. M5 1 here. What did I put here before? 13 or something? Yes. So AC equal to 13 so far. بعدين add M17, I'm repeating, minus 3, so this becomes 10. Here خليها هون 13. Here شو بصير بلا add بصير 10. Okay. Now AC is 10. Load. Oh, I killed this. This should go before this for a correct I'm writing a program, guys, now, huh? You know, cut and here and paste. Right click and paste. Now, I want to save what's in AC, and I want to save the answer, guys. I want to save the answer AC. Load. What? I was supposed to store. Wait a minute. Hey, writing a program on the top of this. Now I need to store first. Right click, copy, and right click and paste. And store in direct in M of 16, M of 16. So this will have the AC and this will have 10 in it. We continue with the program. Load 25 and register 1. So you know that we have a set of registers, مش هيك? So let me write it here. We have set of registers, and it's in the next chapter, guys. But we have been mentioning this a lot. Register 1, what's in it? 25. Equal 25. I didn't kill what is in AC, مش هيك I stored it back. Now, load indirect. Oh, no. It's load. Sorry. Wait a minute. Wait a minute. Load. Now, register is saved, مش هيك? Now, AC is still 10. AC is still 10. I didn't touch on AC. Then load immediate M6. What's an M6? 10. So AC will go back to 10. It's already 10. ما كان لازم اكتب هيك. But anyways, we made sure that AC is still equal to 10. طيب ماشي الحال. Now, here what I'm trying to say. Add the register 1. This is new instruction in my instruction set, guys. Register 1, يعني whatever is in register 1 directly, take that and add it to 10. So after this, AC will be what, guys? AC will be equal to 10 this is plus this is 35 لأنه it added whatever in AC 10 plus whatever is in the register direct register and then store amount. Now this will change to show to 35. This is the best I can do. Material is difficult. Talking to myself, I don't know what you are doing. I don't know, I'm not looking into your faces. This is the best I can do. Livan, okay, thank you, Livan. It's an encouragement for me to keep going. طيب. So this will go down and خليها هيدي ماشي لا شو بدي فيها annotate clear screen for the time being and we continue. Register addressing to wait a minute شو عم اقول هون انا سكرها كلها what okay so the effective address I did this very small address field needed اسمع this is important guys like is this a limited range limited address نحن كنا عم نقول انه الكونستانت is limited to the number that is in the to the number that's in the instruction set. ما فيني اقعد بدون ما اكتب ما بيصير. So let me go and you remember the constant guys here this area was for the constant. We said this is limited range لانه بالاكزامبل اعطيته 4 bits يعني اكبر رقم كان فينا نحطه هون 16 guys. 16 هلا when we mention this as a register now this is a register not a constant then what do we mean by very small address field needed shorter instruction faster instruction fetch you see the register in the CPU in a set of registers 16 registers in the case of CISC mostly and 128 or so register in RISC. And I told you why. I keep reminding you. So if this is the register 1, guys, so if I have only 2 bits here, 2 bits, but this is what? This is a register number. So I go to the register and I access a long number. This register can be 32-bit, guys. So the 5 or the 10 or the 15 that I used it a minute ago can be very large number in billions. So register takes me to register content and it says هون shorter instruction لأنه أنت ما بدك تكتب 32 bit هون as a number. You mentioned the register number and the register had that number but you have to load the register first. And then less when the instruction is smaller in size it takes less to fetch it into the CPU to execute it. And when I have 2 I have here up to 4 registers. If I have 4 bits here I have 16 registers. We'll talk about it next chapter. 16 registers, 16 bit, and this is lots of register to work with inside my CPU. So this is what we're limited number of register depending on number of bits here available. If 2 bits are available for this register field, then we go to 4 register maximum 0, 0, 0, 1, 1, 0, 1, 1. If they are 4 bits, if they are 8, 3 bits, 8 and 16 and so forth. خلاص. I said what I had to say. Now we go with what? Stop it so I can. No memory access, very fast execution, very limited. We did all this, guys. We did all this. Now, and this is how it looks like. I said add register 1. You go directly to this is not RAM. This is set of registers inside the CPU, as you know. This is set of registers inside the CPU. So register 1, 2, 3, you pick it up. 2 bits here, pointing to 4 registers can lead me to a constant or an address. You will see that an address here can go more. Let me show you. Look here, in direct registering in the address. I have to go back and annotate. Listen, guys, now. Look what I have. I have a register number, register 1. I'm using only 2 bits. My field is needing few bits only. I have a set of 4 registers. 4 registers. 2, 3, 4. Okay, fine. I like the system so far. How many bits in the register? This is very important, guys. Suppose 32-bit in the register. Thank you, Levon. So this is 32-bit in the register, guys. So this register is pointing me to a number. This can be a constant, and this can be an address to the RAM. So even I can go from a register address to 2 giga 4 gigabyte RAM, 4 giga بدون ما نقول بايت. 4 giga. How would this look like, guys? Let me show you. خلينا بضلني عم بشتغل هون. Look how it look like. Add I for indirect. هيك. Register number. And this looks like an instruction, guys. ليش ما add I can say add I can separate them. I can do whatever I want. You will see some system use add I, sometimes I separate. خليني احكيها مثل ما كنت عم بحكيها قبل. الاي هون يعني مش هون. add and direct. شو بيجي بيعمل السي بي يو؟ بيقول wait a minute. add no let me separate them. add I لحالها هون لحالها. I am adding something at the end. I'm telling the computer or the CPU that I have a register number. Inside it, there is an address, يعني indirect address in the register. So this can be an instruction set where I am telling the CPU that the register has inside it an address. I should be loading it first, مش هيك? First I have to load the register, مش هيك? with a number. Load أول شيء, يعني load the address. Once I put it in here, the programmer knows that this is an address. Then he writes this instruction. Then what will happen now? That command will go to that register. It will pick up because of the indirect. Because of the indirect. It will pick up this address. It knows that it has to go to the memory. Look, long range of memory now. Look, long range. It will get the number and it will add it to the AC. Great. Read about these, guys. وحدة اللي ما بتفهمها next time you talk to me about. I am telling you all the time. At 12 when we finish, I'm always available. I'm waiting for the recording, and I want to settle my things, and so you can always join me and ask me questions one-on-one. Annotate, and I close annotate. Let me clear the screen, and then close it and go down in direct addressing. And this is how it looks, guys. This is what I was trying to myself draw. And this is the opcode, and this is the register. And how does it know whether it's a register or register address, guys? لأنه previously we said, look, we said register, مش هيك? Register address R, register address R. Look here, register address, it's the same. I cannot write something like this. I have to add something here, like I do I, or the opcode will have to give it away. So if I say add register, it means take the content of the register as the constant. If I say add I and the register, it means the register has not a number but an address, and then you go to the register, you pick up the address, and you go to the RAM. Guys, this line is very important. 2 bits here is leading me to the end of the memory, which could be 32 giga, guys. I repeat, this is very important. 2 bits in the instruction set. 1 bit حتى بيكون register واحد أو 2 registers. 1 bit here, it will take me to the register. If the register is 64-bit register, then it will take me to a RAM of 264 addresses. Yeah, I hope you understand. Next, displacement. Look, I'm gonna stop here now. because this is too much in one lecture. لأنه if we are in person, I would have given you time to do this, to do that. Too much material. I'm gonna stop here and leave the floor for questions. Let me stop the recording so we don't include anything. Pause the recording, stop recording, and yes.